class. Welcome back. Reminder with our flipped classroom model that I expect you to watch the video in Delta Math and take the notes on your note packet that you have open in Kami. You can do this using a split screen or using two devices. Any questions you have, please indicate it, jot it down so that you can ask me during class. Today we are talking about line segments, betweenness of points, and congruent segments. So the previous video we did line, point, line, and plane. A line segment is part of a line with two endpoints. Now a line you can name a few different, or a line segment we can name couple of different ways. Actually, not a couple different ways, one way. This is segment AB, so that would be AB with the line segment on top. Notice, unlike a line, there are no arrows. Betweenness of points. So if we have point M is between points P and Q. So this really means that if I draw a segment, PQ, M is somewhere in between them. This is only true if and only if PQ and M are collinear, meaning they're on the same line. So then what we can decide is what we know is that if PM is this pink line segment and MQ is a green line segment, that if we add the pink plus the green, we get the whole thing I started with as the purple. So PM plus PQ, or PM plus MQ equals PQ, meaning the two parts added together equal the whole thing. So now if we continue down here to segments, segment addition means we can add those two parts together. So if we have RS, where P is someplace in the middle, if we know RP, and I'm going to make that pink, is 2, and we know PS, which I'm going to make green, is 7, then how much is RS? Well, RS is the whole thing together. So we're just going to add 2 plus 7, and it equals 9. Now we can make those way more complicated in these examples. So if we have RS is 2x, so here we find the value of x, RS, if S is between R and T. So I always like to draw it first. So we RT and S is here in the middle. So RS is this part is 2x. ST is 5x plus 4. And then RT is 32. This 72 actually goes over here with this problem. Sorry about that. So that means that RS plus ST equals RT. Each part added together equals the whole. So that means my algebraic equation is 2x plus 5x plus 4 equals 32. And now we need to solve that. So hopefully you remember your algebra. Combine my terms. Then subtract 4 from both sides. And we get 7x equals 28. Divide by 7. And x equals 4. So that's the value for that one. So again, we're going to use the same drawing here. So we have RS and ST equals RT. So that means RS plus ST equals RT. So it's 6x plus 12 equals 72. Here I'm going to subtract 12 from both sides first. It's 6x equals, I wrote 17 instead of 72. Sorry about that. Correct it. Then 72 minus 12 is 60. Divide by 6, x equals 10. So pause the video, give this one a try, and then come back and check your answer. Okay, so hopefully you were able to use what we did in the previous two examples to find out x equals 15. I do want to pick up this problem here because it does ask us for something the other problems haven't asked for, which is to find out how long EF is and FG is. So EF, we know is 4x minus 20. So since we found x equals 15, I'm going to take that 15 and substitute it in for x. So it's 4 times 15 minus 20. And then I just do that on my calculator. And I get that EF is 40. FG is 2x plus 30. So again, I'm going to substitute that 15 in. So it's 2 times 15 plus 30. And we get that FG is 60. So our answer to that problem had 3 parts. All right, so now segment subtraction. Segment subtraction is very, very similar to segment addition, except for instead of adding the 2 parts to get the whole, we're going to take the whole and subtract one of the parts to get the other part. So if we have RS, where P is a point on, and we know RS is 24, so that's our whole, and RP equals 10, we can say that RS, the whole thing, minus this pink little part, RP, equals what's left, PS. So it's really just rearranging it and doing it differently. So here we know that it's 24 minus 10 equals 14. So PS equals 14. Congruent segments. Congruent segments are equal in length. We only say length because remember, a line really doesn't have a thickness. So if we have 2 segments, AB and CD, and say they're both 3 inches, which obviously this is not to scale, we would say that AB is congruent to CD. Oops, and I wrote B when I meant D over here. CD. So this symbol right here is our congruent symbol. And when we say 2 segments are congruent, that means they're equal. So AB equals CD. So now an example. Using the markings in the diagram, tell which of the following is correct. Well, these markings, this dash, is saying that AB is congruent to DC. So that's correct. And if AB is congruent to DC or CD, they're equal. Now the other ones, they're not those 2 parts. But if we look, BC is the same as itself, yes? So therefore, AC, which I just kind of circled in pink, would be the same as BD because they both have one of the little parts and then that pink part in the middle. So the one that is not true is answer 4. And that one was really kind of tricky. All right, so now we'll do this example tomorrow. If you have any questions, please jot them down and I'll see you in class.